Great. You're all welcome once again. Yeah, so we are going to continue from where we ended in our previous lesson. So as we're going through data organization, analysis, and presentation. Yes. So in our previous lesson, we're going through how to find the mean, the mode, and the median when you are given an ungrouped um, um, frequency distribution table. Yes, we also calculated some examples. We calculated the mean, the mode, and the median whenever you have a raw data. All right. So as I said in our previous video, that in our next lesson, we are going to look at how we can find these three um, measures of central tendency. Okay, when you are given a grouped um, frequency distribution table. Yes, so that's what we are going to do today. All right, so my name is Evans. I'm your mathematics facilitator. This is MathsBase TV. Don't forget to subscribe, like, and share. Yeah, so let's move on to what we have today. Okay, yeah, so that is um, finding the mean, the mode, and the median from a grouped frequency distribution table. Okay, so first of all, as I explained in the previous lesson, that when we talk of a group data, that is where um, the data set, okay, that is when they are put into what classes, or they are put into categories or groups, or we summarize them in a table by putting them into what classes. Okay, so those examples that we solved in our previous lesson, you realize that most of the classes were not put, um, most of the data sets were not put into classes. We didn't group them, we just used them as they were. So in this lesson, we are going to put them into classes, and then we look at how we'll be able to find the median, okay, the mode, and the mean from such a table. All right, so let's proceed. Okay, so we are going to have a table like this, okay, because we are going to find the mean, the mode, and the median from such a table. Then we're going to go through these the various headings. So the first heading, we have what class limits, which involves what lower class limits and upper class limits. Then we also talk about tally. So the tally, that is when you have been given raw data, you have been given what plenty data points, then you still need the tally. But in a question or in a case where it is already given in table, you know the frequency. Most of the time, the tally comes in when you are not given the frequency, but you are given a raw data and you are to find a frequency. That is where the tally comes in. Okay, so note that not every day that your table will have tally. You might have tally when you are not given the frequency, but you need to find the frequency, okay, by using the strokes as we did in our previous lesson. Okay, then we also go through what we call what class midpoint. Yes, and then as for frequency, we did it in our previous video. Then we also talk about what class boundaries. Okay, we also talk about that. Then another new thing we've introduced again is what cumulative frequency. Okay, yes, cumulative frequency. So we shall look at all these things. All right, yes, if that's the case, then um let's look at this. So let's go through these various headers. So when we talk of class element, what does it say? We are saying that it is the range of values of the data set. It is when the data points are grouped into classes. So as I said earlier, yes, when we put them into classes. So these classes then, okay, we are also saying that the class element is the interval between a smallest value, which is known as what lower class limit, and a largest value, also known as what upper class limit. Yeah, so that is the upper class limit and the lower class limit. Okay, yes. Now let's also look at this example. So for instance, if you are given this class that is 5 to 10, then our lower limit is the 5 and our upper limit is the 10. Okay, yes. So that's it. Then we also talk about what class midpoint. Okay, or sometimes also called what class marks. Okay, so at times we call them class marks, sometimes too we call them what class midpoint. Okay, what is that? So that one we are saying that the class midpoint is the average of the lower class limit and the upper class limit. So when you find half, okay, of the sum of the lower and the upper class limits, that gives you what a class midpoint or the class mark. Okay, so get that. All right. Then, so for instance, as we are saying, so the class midpoint is what? The lower class limit plus the upper class limit divided by what? 2. Okay. For instance, if you take the example, just 5 plus 10, which is 15 divided by 2, and that gives you what? 7.5. All right. Yes, that is very great. Okay. Now, and let's also talk about the class boundaries. So when we talk of class boundaries, we are saying that they are continuous numerical values used to separate classes in a frequency distribution. So we are saying that it is calculated by finding the average of the difference between the upper class limit of one class and the lower class limit of the next class, and the result is being subtracted from the lower class limit and then added to the upper limit of each class. So what that we are saying is that if you take two different classes, the upper limit of the first class and then the lower limit of the next class, find their difference. Okay, then you divide by 2. Okay, then after dividing by 2, whatever the result you get, then you are going to you add it to each class, you add it to the lower limits, and you subtract it from the lower limit, and then you add it to the upper limit. That is how it is done. So for instance, let's take this. So let's say we have these two classes. First class is 5 to 10, second class is what, 11 to 15. So we we take the 10, which is the upper limit of the first class, then 11, which is the lower limit of the second class. Then we find the difference and divide by what? 2. You know that we are going to get 0.5. So after getting the 0.5, how do you get your class boundary? So you go to the first class, the lower limit is 5. So you add the 0 point and you subtract the 0.5 from the 5, then you add it to its upper limit and you get 4.5 is to 10.5. Then you do the same. So you subtract from each class its lower limit, but you add to each class its upper limit. That is how we used to get what we calculate the class boundaries. Okay, so in a question, when you are asked to calculate the class boundaries, that is the procedure you follow. All right, great. Now let's talk about the cumulative frequency, that is the CF. So what does this say? It says that it is the running total of frequencies in a delta hot set calculated by adding rows frequency to the sum of all preceding frequencies. So this one, what you do is that if you take the frequency, eh, to get the cumulative frequency, you start from the very first number of the frequency. Then to get the next cumulative frequency, you add the next value, okay, in the frequency to the previous one to get what the cumulative frequency. That is what you'll be doing until you get everything. And note that the last cumulative frequency should be equal to the total, okay, the sum of the frequency. So get to know that, all right? Great. So if you take example like this, and we know that we have 5, we have 3, we have 8, we have 2, we have 4. So how do we generate the cumulative frequency? Yes, let's quickly look at how we are going to do that. All right, great. Yes, so this is what we have. Now you know that the first number for frequency is 5. So we'll begin the 5, okay, for the cumulative frequency. So we'll put the 5 there, okay. That is what we begin with. Then to get the next number for cumulative frequency, I will add the next value of the frequency to the previous one, which was 5. Okay, so 3, I'll add 3 to 5, making what? 8. And then to get the next one, I'll add 8 to the 8, getting what? 16. Then the next one, I'll add 2 to 16. Then I will get what? 18. Then the next one, I'll add 4 to 18. And then I will get what? 22. So that is how it is done. Okay, you'll be adding the the frequency to the previous value to get what? The actual value for cumulative frequency. All right, that is great. That is how it is done. So, my dear student, when you are asked to calculate for the cumulative frequency, that is how we go about it. All right, great. Now, let's take this as an example. So we are going to use this table. We are going to use this to find the mean, the mode, and the median. Okay, we are going to, this is what a grouped data. So you see that the marks are put into what? Classes. So first class is 0 to 9, 10 to 19, then it follows like that. Okay, so once we have been given the frequency already, then we don't need tally. Okay, as I said before, you get your tally unless you don't have the frequency, but you have been given raw data, then you get your tally to help you get your frequency. So let's have our table. So this is what we are going to have. Okay, so we are going to have frequency. Yes, the frequency and the marks were given already. So we are going to work for class midpoint, fx, class boundary, and cumulative what? Frequency. Okay, so we are going to work with the um, class midpoint. And as we did in our previous lesson, we said that to find the class midpoint, how do you do it? You just find what? Um, the average of each class what? Each class. Okay, so if that is the case, then we add 0 to 9 and divide by 2 for the first class, and that gives what? The class limit and the class midpoint. Then we did the same thing. So we'll do that, we'll add all of them. Okay, just find the average of each class, and that gives you the class midpoint for each class. So if that's the case, then let's go to our table and fill our table. So we fill our class midpoint. Now let's find our fx. As for fx, we did it in the previous one. Now know that uh, in this group data, our class midpoint becomes our x. Okay, unlike the ungrouped one where your x will be your range. Okay, but this one, your class midpoint will be your x. So we just have to multiply. So 2 times 4.5 gives us 9. Multiply the rest. So you do that 15 times 24.5, then 10 times, yes, do that one, and you are good to go. So now that we have our fx, let's also calculate for class boundaries. And as I said before that, you need to find the difference of this, okay, the upper class of the upper limit of one class and the lower limit of the next class. You find the difference, okay, that is 0.5. Doesn't mean every day you get 0.5 depending on the numbers given. You might at times get more than that or lesser than that. So take note. Okay. So once we get that, then we go to each class and then we subtract from its lower limit and add to its upper limit. So the first one is 0 to 9. So we subtract 0.5 from 0 and add to 9. Okay. Then we are going to get what? Negative 0.5 to 9.5. It continues like that. So we can do that. So when you can sit down and calculate, okay, and then we get everything. So now that we have calculated our class boundary, so what is next? Our next thing is what? How to calculate our cumulative frequency. Very easy. Okay, and I've explained that already. Good. Yes, great. So That is it. Okay, so let's find the cumulative frequency. Now you know that, as I said, that for cumulative frequency we start from what, the 2, okay, of the frequency. Okay, then we'll be adding. Okay, we add the 3 to 2. Okay, yes, making what, 5. Then we add the 15 to 3. Okay, and we add to 5 already because we have gotten 5 in the cumulative frequency, making what, 20. Then we add the 10 to the 20, making what, 30. Then we add this 10 again to the 30, making what, 40 exactly. So that is how it is. And now that we are able to generate all these, we have been able to fill our table. Now let's find the totals. Okay, so for this one, we find the total of the frequencies and then we find the totals of the fx. So sigma f, if we add all of them, we are going to get 40. Then our sigma fx, if we add all of them, we are going to get what, 1210. So now that we have calculated this, then let's proceed and find our mean, our mode, and our median. All right, great. So if that's the case, since we have this, then let's start with our mean. We know that we did it in our previous video, that um, our mean, which is represented by what, x bar, is given as what, sigma fx divided by sigma f. So once we have these values, we just do substitution and we are good to go. So our mean is given as what, 30.25 and 30.25. All right, that is our mean. Then let's move on to our mode. Now, before we find the mode, you know that if you talk about frequency distribution table, we are going to have our modal class and we also have our mode. Yes, there's difference between the modal class and the mode, so that in the question when we ask you don't get confused. Okay, so for the modal class, what does it say? It saying that it is the class with the highest frequency. Okay, so unlike the previous one where when you are given group data and you are asked to find the mode or the modal class, you are only going straight away and find what, the class with the highest or the mark or the range with the highest frequency. But this one, you have to find the modal class and find the mode again. Okay, so we go to our table, then we are saying that the highest frequency, and we all know that the 15 is the highest frequency. So we trace it to its corresponding class, which is what, the 20 to 29. So it means that our modal class is what, 20 to 29. Very great. Now let's find the mode itself. Yes. Now for the mode here, my dear student, it is very critical. We are going to use a formula, and this formula, I want you to keep it in mind. Okay, you need to study the formula carefully. Other than that, you'll find it so hard or so difficult to find the mode. Okay, so this is the formula we are going to use. Okay, so as I said, I entreat each and everyone to take this formula very, very much serious so that in the question, when you are finding the mode, you can use this formula to find the mode. Now let's define the letters in the formula. So for the L stands for the lower boundary of the modal class. So we have already calculated the modal class. So we are saying that the lower boundary of the modal class, we will find that in our table. Then the F subscript, yes, subscript what? One is what? The frequency of the modal class. So once we know our modal class, we can find the frequency. Then the F subscript what? Zero is also what, frequency before the modal class. So we can also find the frequency before the modal class. Then F subscript 2 is also what, frequency after modal class. So everything is on the modal class. So once you know your modal class, you can get it. That's why it is very necessary you find your modal class. Then the H in the formula is what, the class width. So we are going to find out what is the class width. The class width sometimes also called what, class size. Yes, so sometimes we see class size. So if you don't see class weight and you see class size, know that we are talking about the same thing. If that's the case, then let's go to our table. We can find our lower class boundary of the. Yes, so we know that our modal class is what, the 20 to what, 29. So we are looking for the lower class boundary. of that class. So we trace to the lower class boundary. Yes, that is the lower class boundary for the modal class. So now we know that our the answer for that is 19.5. Then we find out the frequency of the modal class. So we go back to our table. What is the frequency of the modal class? So we know that modal class is still what, 20 to 29. So our frequency for that is 15. So we know that that one too is 50. So as I said, it is not difficult. So we don't see the formula as something so difficult. Okay. Yes, it's just that you are only finding values for this and then you do your substitution. Then we find what the frequency before the modal class. Okay, so we go back to our table once again. Now we know that for our modal class, that is 20 to 29. Now, and each frequency is 15. So we are talking about the frequency before that 15. So we can see that it is what, the 3, because that is the frequency before the frequency of the modal class. So that one too, we have our answer as 3. Then we find the frequency after the modal class. So that one, we go to our table again, and you also know that if the 15 is the frequency of our modal class, then what is the frequency after the modal class? Then you know that it's going to be the 10. Very simple, okay? So it means that that one is also what? 10. Then we find the class width. Now let's know what the class width is. All right, so let's find the class width. So what is the class width at all? So remember I said that when we talk of the class width, it means what, the class size. So there are times you see class size in some books. You can also see what class width means the same. Okay, so when we say class width, we are saying that it is the difference of the upper class boundary and the what, lower class boundary. Yes, that is the class width. So when you find the difference, if you realize that the difference is running through, okay, that gives what, the class width. So let's go to our table and then identify. So we know that these are our class what, boundaries. So let's glance through and see. So we know that the first class boundary is negative 0.5 and 9.5. So let's find the difference. You realize that if you subtract negative 0.5 from 9.5, you are getting what, 10. And then the next class boundary is what, 9.5 to 19.5. And if you find the difference, it is also 10. So you realize that if you find the difference for each of the class boundaries, you are getting 10, 10, 10. So for that matter, our class weight becomes what, 10. So if that's the case, then we can conclude that our class weight is what, 10. All right. So now that we have been able to find all these answers for these letters, then we are good to go. We have to what, find a mode using the formula. So as it is given, then we just substitute the values and then we are good to go. Okay, so once you find the mode, in that case, our mode is going to give us what, 26.56. So that is the mode. So my dear student, as I said, you need to keep this formula very hot. Well, yes, you don't have to joke with this formula, so that whenever you are given any a question to find the mode, especially when you are given what, a grouped data or a grouped frequency distribution table, this is how you are going to go about it. All right. So if that's the case, then let's move on. Now, let's also find our median. But before we find our median, let's find what, the median class. Okay. So for the median class, let's come to um our table. You know that before we even find the median, we also need what, the median class. Okay, and then the median class, you know that we when you added what, frequency, you got what, sigma f as what, 40. Yes, so the 40. Now you know that, remember when we're doing ungroup data, when you are finding the mean, especially we use what, the position. Okay, we use the position where we talked about what, when it is even, you we talked about how to find it. When it is odd, that is when the number of entities, okay, if you realize that the number of entities is even, we talked about how to find it if it is odd. So in this case, the same here. So the sigma f represent what? The number of entities or values as we did in our previous lesson. Okay, so the total is 40. So is it even or odd? We can see that it's obvious that it's what? Even number, because we have 40. If it is even for grouped data, then we need to find the half, okay, of this. Then the answer we get becomes our position. Then we go to our table and find the position of that. Okay, and we know that since sigma f is 40, then we find half of what? 40. And that's going to give us what? 20. So it means that we have 20th position. So we'll go to our table and either in the cumulative frequency or in the frequency, we find what? The 20th position, and that will tell us the class. You get that? Yes. So um remember also that because this is even, someone may ask, what if it were odd? So if it were odd, remember when we're doing odd, then we would have added 1 to 40. Okay, for instance, if maybe the sigma f were to be maybe 39 or 41, would have added what? 1 to 39 to make it 40, to make it even, so that we divide by the 2, we find the half. If it were to be 41, we would have added 1 to the 41 to make it 42. All that we are trying to do is to make it what? Even. Great. Yes, so all the idea is that if it is odd, we just add what? 1 to it to make it even, so that we can find the position easily, because we don't want the point. Okay, we don't want the decimals. Okay, all right. Now, if that's the case, then let's try and go to our table. Okay, yes, let's go to our table and then we find the 20th position. Now, remember what we did in our previous lesson when we had to find the position. So we go to the frequency and we'll be adding from the top. We'll be adding until we reach a figure. We didn't reach the 20th, the 20 that we have gotten is there. Okay, so in this case, in the table, it's either we go to the frequency, okay, or we go to the cumulative frequency to find the 20th position. All right. So because we are going to identify which class. So in that case, we know that the first value for the frequency and for the cumulative frequency, they are all what? 2. So for the frequency, we know that we have 2 there. So, and we have, when we calculated half of 40, we got 20. So 20 is greater than 2. Then we have to move on to the next frequency and add it. So we will add 3 to 2, we get 5. So still 5 is less than 20. Then we have to move on to the next frequency, which is what? 15. Then we add the 15 to the already 5 that we have gotten from the 2 and the 3. If we're able to get 20, then we trace it. So you see that 15 plus 5 gives us what? 20. So this one has given us exactly 20. So when it's given to you exactly 20, then it's not difficult to find that. Then that 15 that we have gotten, the 15 that we reach before we got the 20, then we trace to its class. So you see that the class is what? 20 and 29. So that is class. In that case, that becomes what? That becomes our median class. So our median class is what? 2029. That is it. Perfect. Okay. Yes. So now that we have calculated or we have found our median class, then let's go ahead and find the median itself. So for the median, remember when we're finding the mode, we use a formula. The median too, we are going to use another formula. Okay, and this is what the formula we are talking about. So, my dear student, I entreat you to keep these two formulas, the formula for the median, the formula for the mode. Okay, I entreat you to keep them so that you don't forget them whenever you are given a question based on what? On grouped data, then use these two formulas. And these two formulas are going to help you when we get to percentiles, deciles, and all that. We will still use this formula, except that only few things will be changed here. Okay, yes. So let's also try and define the letters. So for the L in the formula,
we are saying that the L is what? The lower boundary of the median class. So remember when we were talking about the mode, the L was the lower boundary of the modal class because we were dealing with mode. So in this case, whilst we are dealing with what? Median, then it will be median class. So take note of that. So it means that we will have to find the lower boundary from the median class. Then our CFB is also what? The cumulative frequency before the median class. So we will also look at that from the table. Then the F subscript M is also the frequency of the median class. So we will find that one too. And as for the H, which is the class width, the same thing we got from the mode. We are using the same thing because as for that one, it doesn't change when it comes to the median. It is the same thing. Okay, so if that is the case, then let's go to our table and find the L. Okay, yes. So if we come here, then we know that our median class, that is what? The 20 to 29. So let's find the lower boundary. So we trace it to the class boundaries. Now you see that the boundaries, we have what? The lower boundaries and the upper boundaries. So the lower boundaries are the first figures and the upper boundaries are the last figures. So if you take that class, we have 19.5 and 29.5. So the 19 is our lower class boundary and the 29.5 is our upper class boundary. All right, great. Yeah, so in that case, our lower class boundary is the 19 point what 5. Yes, that's it. So then we go there and then we know that our L is what? 19.5. That is very great. Now let's look at our cumulative frequency before the median class. So let's go to our table once again. Good. Now we are saying cumulative frequency before. So you realize that for cumulative frequency for the median class, we know the median class is 20 and 29. So if you trace it, each cumulative frequency will be 20. And in that case, we are saying before what? That media class. If before, then automatically we are talking about what? 5, because it should be less than the cumulative frequency for the median class. So in that case, that is the 5. Okay. Yes. So we conclude that our cumulative frequency before median class is what? 5. Then we find the frequency of the median class. Let's go to our table once again. So we still know our median class. Then we just find the frequency of that and we know that that is what? The 15. Okay, in that case our frequency of the median class is what? 15. Great. Then as for the class width or the class as we've already calculated, we got it from the mode. So that one we got what? 10. Yes. So once we know this again, what do? We just substitute our values and then, but yes, but let's talk about the sigma f over 2. Now you see that is what we have already calculated. We calculated, we found what? Half of it. That was the 20th, the position we used to get the median class. So that sigma f divided by 2 in the formula. It is the same thing we have calculated, and that was what? The 20 we got. So in that case, that that thing is also what? 20. So once we know all these things, then we substitute our values and then we are good to go. Okay. Yes. So that is very simple. So our median is now going to be 90.5 plus 20 minus 5 all divided by 15 times 10. And then we move on, we calculate, and then we have our median as what? 29.5. So you see, this is very, very simple. Okay. So my dear student, when you get questions like this, very, very simple. All right. Yes, that is wonderful. Good.
So, my dear student, that is how we find what? The mean, the median, and the mode of a grouped frequency distribution table. So, I know we've gone through all this when it comes to ungrouped data, ungrouped frequency distribution. So, we have gone through all these things. So, please um, take your time, watch the video, okay? Wherever you are finding difficult, you are not getting it, you can pause and come, go back and watch again. You can watch it as long as so that you get it's very, very easy. All right. So if that's the case, then let's end here and continue next time. So in our next lesson, we shall be looking at the word problem application questions of these three um, measures of central tendencies. All right. So if that's the case, then let's end here. Continue next time. My name is Evans. I'm your mathematics facilitator. The name of this channel is Mathswiss TV. Don't forget to subscribe, like, and share. So see you next time. Bye bye.